This is a little bit of help with inverse functions, and you may have noticed I'm skipping section 1.8 because I sensed that people were not having trouble with it. If that's not true, then feel free to give me a holler with that. So the question is, if you have some kind of function, let's say this kind of ugly, how do you plot the inverse function of that mess? Well, first of all, you should realize something. Is this a function? Yes, because there's something called the vertical line test. If you take this vertical line like this and pass it through the function as you march along, it only touches the function at one point anywhere. But what about if you took a horizontal line and did the same thing? Then, well, it's mostly okay, but every so often you're going to get, whoops, you're going to have some horizontal lines will cross the function in more than one place. This means that the function is not invertible. So it's invertible up to here. This little part is ambiguous, and then the rest of it's invertible. Okay, so that's the first thing to note. Now, that being said, I'm going to just show you artistically what's your objective here. Your objective is you're supposed to reflect through the y equals x line, and if the original function is invertible, what you will get is the inverse function. Okay, so hold on a second. I'm going to just do some ruled paper, some graph paper, just to make this a little easier to see what's going on. Alright, I'm going to try to line this up on an axis somewhere. Okay, and so I did a really poor job of estimating the line y equals x. Let me do a better job here. Like that. That's a little better. So now I'm going through the line y equals x, and I'm going to pick like red for the color of my inverse function. So blue is f, and red is my inverse function. First of all, anywhere I cross the axis, anywhere I cross the y equals x line is going to be the same for f and f inverse. And I'm just going to artistically try my best to estimate what's going on here. This is a very artistic process here. So don't worry about what it means mathematically at the moment. Just try to make a butterfly out of this like you did when you're in grade school. Try to make this mirror image as much as possible. Okay, try to figure out, so what your eye should be doing is, if I'm looking at this box, I'm looking at this box. And here I'm looking at this box and this box and trying to make them match in mirror image. And then I'm going to look over here, and I'm going to look over here. I'm going to try to make them match. So I show you a really clever way of doing this in class, that if you just take your pencil, and I have you just go like this on top of the original curve, okay, and then you fold along this line, and then you take your pencil and you just scribble like this on the back. Scribble, scribble, scribble. It has to be a pencil. Actually, some students have made it work out with pens anyway. And then what you get is you get a little trace mark, and then you can go over with your pen and say, oh, okay, I see it. I'm going to make it look nicer now. And you kind of sketch it out until it looks just so. Okay, so you can use artistic tools to help you get the inverse function. Again, this is not actually an inverse function because the f is a function, but f inverse is not a function because f was not invertible to begin with. But the artistic process is the same. Okay, so that little introduction, hopefully that made sense. Now I'll tell you a little bit of mathematical explanation about what's going on. So for any function, if you have a and b as a point on function f, if the function is invertible, then there's going to be a point b comma a is on f inverse. Okay, and again, f inverse is going to, who knows what it looks like. It's going to be mirror image along the line y equals x. Along the line y equals x. Okay? Okay. So now let's go to this question. What questions were you given in section 1.9? So questions 17 through 20 in the book, it says, use the graph of the function to sketch its inverse. I'm not going to use the exact same questions in the book, but I'll use something similar. Okay, so what if in the book the function looks like that? How would you find the inverse function of that? Well, you draw the line y equals x, and then you mirror image this. Mirror image. So the biggest mistake students make is they do a mirror image along something else. Like, I'm not even going to say what, because you don't need to think that way. But whatever it is, they don't draw the line y equals x. So draw the line y equals x. Here's an interesting point. It's over 3 up 0. So that means if you go up 3 over 0, that point must be on the inverse function. Let me find another point. The point negative 3, 0 is on the green curve, so the point, 0, negative 3 is here, so negative 3, 0 over here, this must be also on the inverse curve. And then this doesn't seem like it would be too hard to mirror image. It's not perfect, but that's probably good enough. Okay, so if you're doing this for an exam or something, that would probably be considered good enough. So what you want to do is visually look at this point and say, aha, this is about 1.5 units away. That looks pretty good. So you should be able to measure this way, perpendicular to this blue line. Okay, and that's the mirror image you're looking for. Okay, so these little arrows going, like that arrow should be the same length as that arrow, and so on and so forth. Okay, so that's how you do those problems. Again, if there's a point that's easy to reference, find the opposite point over there. All right. Now, what else is in that? 35 and 36. Number 35 to 36. What is that asking? It's using a table to find F inverse, and that's really easy. It's so I'm going to do something like 35 and 36. If you have x and f of x, whatever, right? And you're going to have like -3, -2, -1, 0, 1, whatever. And I'm going to make up some numbers. It has to be strictly increasing or strictly decreasing, or else this isn't going to work. If the thing is not strictly increasing or strictly decreasing, then you can't invert the function. Okay, so it says complete a table for F inverse. Well, this is kind of dorky, but this is all you have to do. Etc. Okay, you just flip all those around, and that's really all you have to do. No big deal. A lot of these questions, it's just knowing what you need to do, and what you need to do isn't actually hard. Composition with inverse functions. So this is combining your concepts from section 1.8. So this is number 89 through 92. So some facts. Notice that f of g of x can be written as f of g. Alright, and so when you write g inverse compose f inverse, it just means g inverse of f inverse of x. That's all it means. Or if you, here's another concept though. F of g inverse means G inverse and then F inverse. Okay, so here's what's going on. Let me explain why that happens. F of G of X inverted means undo this action. Okay? And what is that action? X goes in here to G, and whatever comes out, we call it G of X. It goes in through here, and you end up with F of G of X, right? That's the action F of G of X. Now, how do you undo that? What you're doing is you're saying, I'm starting here with something I'm calling X, but if I'm pushing backwards through F, now it looks like F inverse, because I'm coming the other direction. So this is F inverse of X. Then I'm pushing it backwards through here, so now it's G inverse. So it's going to be G inverse of F inverse of X. Okay? So another way to think of it is, I want you to think of this as putting on your socks and then your shoes. What happens is, first you take off your shoes, then you take off your socks. When you do it in reverse, you have to undo everything in the reverse order. So socks on, then shoes on. And to reverse is going to be shoes off, then socks off. If you remember this, then you won't forget that when you do this inverse function, you say this is shoes on, socks on. First you take your socks off. Sorry, I said that backwards. Put your socks on, then you put your shoes on. When you take them off, you got to take your shoes off first and then your socks off. It's exactly the same concept. Okay? There you go. So what did they do? They actually gave you a specified function. So I'm going to say f of x, I'm going to give you a different f than they did. And g of x is equal to x plus 1, let's say. Now, there's two ways to find f inverse and g inverse. One is, you can do the following. Y is equal to 3x minus 2. If I want to find the inverse, you can just flip x and y and then solve for y. Okay? And so f inverse is x plus 2 over 3. But the way you can do it also is the cheating way, which I like, is to think of it as shoes and socks. You put on your socks, this is the socks, and this is the shoes. Just think of what order it happened in. If you put on your socks and then your shoes, you have to take off your shoes and then take off your socks. So if the last thing you did was minus 2, the first thing you have to do is plus 2, and then the first thing you did was times 3, then the last thing you do is divided by 3. So you can think of it as a procedural, step-by-step procedural thing, or you can do this algebraic manipulation to figure out what order it has to be in. Okay? So let's take the shortcut here again. If I actually did nothing, I just added 1, so the inverse is subtract 1. That's pretty easy. And then if I were to ask the question, what happens? Well, I need to invert f of g of x. So if this guy is my socks, and this guy is my shoes, and I need to undo that, first I have to take off the shoes, and then I have to take off the socks. Alright, so what it means is g inverse is x minus 1, but what is g inverse of f inverse of x? So it's x plus 2 over 3 is my f inverse, and then minus 1. Okay? Another way to do that, to double check yourself, is you may say, hey, wait a minute, why don't I compose f and g? This is a video, so I don't feel bad erasing anything. You can always go back and check. All right, so I'm going to just compose f and g. So I'm going to actually calculate that and then take the inverse. F of g of x okay, now the inverse of fog, it says, okay, I multiply by 3 and then subtract 1. I'm sorry, then add 1. So I'm going to just subtract 1 and then divide by 3. Is that what I said? That is actually what I said, but let's see if this is true. Yeah, it works out. Okay, because this is going to simplify to minus 1 over 3, which is what we have over there. So we're good. Okay, so in mathematics, there's often more than one way of getting the same answer. And so I'm going to erase all this garbage here. And the point is, we got the same answer 2 different ways. All right, it's all good. So sometimes if you're confused one way, just do it a different way and don't really stress out about it. This particular concept, I'm more interested that you get the concept. The manipulations can be annoying sometimes. The concept is most important to me. And to me, the base concepts that you want to take away from this chapter is when you see this, and this is an alternate notation for the same thing, okay, but this is the base concept. It means do G first. That's really important. I want you to know that means X goes into this G thing, and then it goes into this F thing, and then what comes out is F of G of X. That's what I want you to know. And that when you want to undo it, you have to go backwards, so you have to undo F first and then G first. It's the shoes and socks thing. Okay, that's the important concept. Hopefully that helps.